Thank you. All right. Probably, Selahattin, you are recording on your side, but it doesn't show from my side. I just started recording.
I think for all of us, like when I stop, like it will post automatically.
Okay, I see.
Mhm.
All right. Thank you very much, Selahattin. All right. So let's see. Okay, I'm gonna share my screen now. Screen share. And in the coming weeks, we are gonna meet more often. We are gonna solve some more problems. Okay. So keep this in mind. For example, Monday and Tuesday classes we are going to meet. Tomorrow, Thursday, I'm gonna go to inspect other departments at school, so I won't be available on Thursday. On Friday, I could be available. I will send you an email on Thursday if we are going to meet on Friday, just to solve more problems, okay? And next week, on Monday and Tuesday, we are going to solve more problems together, okay? We'll meet more often in coming weeks. Because yeah, we have to get you ready for the final exam. Okay, I want to get to this one.
Teacher, we can see your screen right now.
I know. Let me do that. Okay, now here you go. Okay, what we are going to do. Here is the list actually, homework 5, PDF format. And we are going to go through this. There's actually close to 20 something questions. Okay, so this is using rectangles whose height is given by the value of the function at the midpoint of the rectangle space. Estimate the area under the graph using first 2 and then 4 rectangles. We are going to do first 4 rectangles maybe, but this is, let's see, let me do that. The answer is given below here as well. And they want us to, let me get a pen. And what is important, let me try to copy this, copy and paste to our other part. If I can do that, it's going to be easier for us, okay? Hopefully I'm going to be copying this correctly. Let me open up a new page. This is at page. What is that? Just a sec. Okay. I'm going to rename them later on, okay? So you have to rename it right, not that. I think it's somewhere. Nah, it's this. Okay. So this is page 2 actually, because page 1 was in the morning. Review. Chapter 5 review. Chapter 5 review. Okay. All right. So this is homework 5. If I say question 1, each time it randomly shuffles it. So I shouldn't say, this is not the exact question 1 in your homework 5 because it shuffles. So it could be a different number in your case. I'm going to just copy the question and, okay. And then we work on it. It says use the rectangles. If this is easy, I can skip this question, by the way. If you don't want me to do it, I can skip it. You just tell me, and then we can save more time like that. Do you want me to solve it? So this one? Yes or no? Can you not hear me?
We can do it fastly, as you know. Beginner to hard, maybe.
Okay, let's solve it. Okay, so solution. So You want me to solve it, right? Okay. All right, so this is the graph. Y is equal to x cubed. So this is the graph that we know of. And they are interested in between 2 and 4. So this is 2, this is 4, yeah? So they want us to estimate the area under this curve. Okay, we want to estimate the area. And we are going to use the rectangles to do that. But we are going to also be careful. We are going to use the midpoint of the rectangles. Okay? We estimate the area under the graph. Okay? But I'm going to use 4 rectangles. It says 2 and 4 separately, but I want to do just one. And I want to just do the n is equal to 4. Okay? So I'm going to draw this bigger here. Okay? So just consider this picture. This is the x-axis. This is x is equal to 2. This is x is equal to 4. Okay, and then I'm going to divide it into 4. So between 2 and 4, okay, what is delta x? Delta x is b minus a over n. All right, so delta x here, what is my b? B is 4. What's my a? A is 2. What's my n? N is 4. So n is 4, by the way. N is 4. So this is going to give me 2 over 4, which is 1 over 2. So the intervals, subintervals have the length 1 over 2. Okay. So this is 3, and this one is 2.5, 2.5, and this is 3.5. Okay. Now they are saying use the midpoint. So I'm going to change my color to a red one, and then I'm gonna say, okay, so this is the midpoint of this. This is the midpoint of this. This is the midpoint of this. This is the midpoint of this, and then I'm gonna go up and then find the f value. Go up and then find the f value. Then I draw my rectangle. Okay, this is the rectangle I draw, the first rectangle, and my second rectangle is this. Okay, my third rectangle is this height, so it's going to go until here. This is my third rectangle. Okay, and then it is this height, right? I just follow that, and then my rectangle is going to be this. Okay, so how many rectangles? So let's use some other colors. So this is my, let's see, this is my first rectangle. This is my second rectangle. This is my third rectangle. This is my fourth rectangle. Okay, all right, it just didn't go through. Okay. All right, then I'm going to start. If you go up, just a sec. If we go up here, it says using rectangles whose height is given by the value of the function at the midpoint of the rectangle's base, estimate the area under the graph using first 2 and then 4 rectangles. Okay, my function is y is equal to x cubed. So I'm going to start writing my Riemann sum. Okay, the Riemann sum is, okay, I'm going to write Riemann sum. Riemann sum for n is equal to 4. N is equal to 4 and midpoint. For midpoint, yeah? Okay, it's gonna be equal to, all right? So I go a little bit down. Remember, we have y is equal to x cubed. So this is gonna be, what's the formula? The formula is, I'm gonna call it C1, C2, C3, C4. The names, and I can find the formula for them. Okay, so this is going to be delta x times f of c1 plus delta x times f of c2 plus delta x times f of c3 plus delta x times f of c4. All right, so let's go down a little. But what is C1, C2? Okay, okay, C1 is the middle, which is 2. Let's go up here. It is the midpoint of 2 and 2.5. So you are going to add them up and divide by 2. So this is going to be 2 plus 2.5 over 2. And then C2 is, what is this? This is 4.5 over 2. This is 2.25, yeah? And then this one is 2.5 plus 3 over 2, which is going to give us 275, yeah? 5.5 over 2. 5 over 2 is 2.5, and 0.25 comes 2.75. Okay, and then C3 is going to be similarly, see, this is increasing by 0.5, yeah? Increasing. So C3 is supposed to be 2 points, I mean, not 3 points, what? If you add 0.5 here, 3 point, let me erase that because it doesn't look as nice. So let me erase that. Okay, so this is going to be 3.25. All right, and then if you go down, C4 is, we are going to add 50, 0.5 to it. So this is 375. Again, you find it similarly. I mean, just you add these up, 7.5 divided by 2. It's going to be 375. You get it. Okay. So we got all these numbers. And then, so area, okay, the estimated one, we are estimating it, not the exact area. Estimated one, delta x times f of C1 plus f of C2, f of C3, f of C4. You add them up. Delta x is equal to 1 over 2, yeah? F of C1 is f of 225 it was, right? 225, I guess. 225, 275, okay. 2.25 plus f of 2.75 plus f of 3.25. I mean, is it? Yeah. Plus f of 3.75. I'm just double checking. That's why I just hesitated. But what is f? F is x cubed. So 2.25 cubed plus 2.75 cubed plus 3.25 cubed plus 3.75 cubed. Okay? So then what? So you just add them up. I don't know. So we can go to Wolfram Alpha. We can calculate it from Wolfram Alpha if you want. Let's open it up. Let's see. I think Wolfram Alpha was open somewhere. Just a sec. Let me find it. I think I made it available in my previous class. It should be somewhere here. Yeah. Okay. What is it? Okay. So I'm going to open that up, and then 225 cubed. Okay. Plus 2.75 cubed plus 3.25 cubed plus what? 3.75 cubed. Yeah, and then divide this by 2. Yeah, 0.5. What is this value? Let's find it out.
2.75'i karesini aldık.
Oh yeah. Oh my God. Okay, thank you for the correction. Okay, let's redo it. Okay, what's it? 59,625. Let's go back to it. 59, approximately 60. Okay, so this is 59,625. It's approximately 60. Yeah. Okay, this is the area estimated under this given information. Okay, that's it. So let's continue with the second. Any questions, guys? If you have any questions, please let me know. Otherwise, we are going to do 2. Okay, let's do 2. Okay. Which of the following expresses this in sigma notation? It says, okay, let's copy paste that. and work it out here. Okay, Control V. Okay, and make it a little bit bigger for you. Okay. Oh my, this was smaller. Let's go down a little. Maybe 26 is better. Okay. Okay, how would you decide? You can just look at the answers and then decide and exclude some of them and then get to it. Or you can just say, okay, this is 1 minus this is 4 squared plus 4, just a sec. This is 4. I made a mistake. This is 4, not 4 squared. I just jumped to the next one. Okay, 4 squared minus 4 cubed plus 4 to the 4th minus 4 to the 5th. Yeah, so this is how it looks like. And then we want to write it in sigma notation, but this is minus and plus. How should I do it? Maybe I just give it a try. Maybe I should do like 4 to the k, and then k is starting from 0 to 5, 0 to 5. And then, but how about the minus I have to take care of? And negative 1, okay, negative 1 to the k, maybe it's going to work. Let's try it out. So for k is equal to 0, this is 0th power, which is positive 1, and this is 1. So this is the first term, okay. The second term, k is equal to 1, this is negative, good. And then for that, that works. K is equal to 2, this is positive, it is 1, and 4 squared. So this works really, okay, this works. But there could be some other ways to explain it too. Okay, it's not maybe the unique way to do it. For example, let's give it a try. Maybe this is going to work as well. We call this k as a dummy variable. We are going to talk more about this in chapter 9. In chapter 9, we are going to be talking more about these sequences, series, etc. This k here is called as dummy variable. Let's plug in 1 here. If you plug in, this is 0th power, so it is 1. For k is equal to 2, it is 2 minus 1 is 1, negative 4. This works. K is equal to 3, it works as well. So k is equal to 6, it is 5, so it gives you this. That's perfect. So this is also okay. So you can express the same expression in different format. So let's look at B. K is equal to 0. This is 1. K is equal to 1. This is okay. K is equal to 2. This is also okay. So this is another, this is what we had done actually. This is our answer that we had talked about. So this is also okay. Let's move towards right. I'm going to try to, it doesn't. Okay. So the C doesn't show up because it just didn't include it. That's not good anyways. Okay, this one is here. So for k is equal to negative 2, plug in negative 2, it is negative 1, this is negative, so it doesn't work because the first term is not negative. So this fails, but A and B is the right answer. Okay. Let's see the next one. The question is, how would you find the derivative of this when, so I'm going to copy this to the other side, okay? And then work on that together. Not that. Just a sec. I want the snapshot. And I want to do the undo. Okay, I want to do the snapshot. Snapshot is much better though, yeah. Why didn't I think about that? Okay. Let's move it to the other side. Okay, this is question 3. Okay. Snapshot is the best. Yeah, in the morning I didn't think about that for some reason. I don't know why. Okay, now I figured it. Control V. Let's see. Yeah, perfect. That's really nice. I like it. Okay, this type of question, how would you think? Okay, this is related to fundamental theorem of calculus 1. Fundamental theorem of calculus part 1. Okay, solution. Before I get to the solution, actually, I want to show you more examples on that. This is easy, but there are different versions of it, which is going to be harder than this. Okay, this is related to, I'm going to tell you here, by fundamental theorem of calculus part 1, we get, I'm going to give you the answer, but I want to show you more. Okay, dy du is going to be equal to, So we have this f here, right? Okay, just a sec. This is little f, right? F of t. F of t. Okay? dy du is going to be equal to f of u by fundamental theorem of calculus part 1. So this is going to tell us then the answer is 9 plus 10 u squared. Okay? This is done. So this is very easy, but there are different versions and maybe harder versions of it. I want to share that with you in ebook, e-text, e-text here. E-text, we should have it somewhere here. Let's open this up. Are we still connected? Can you hear me?
Yes.
Okay, perfect.
Yes, teacher.
I'm happy when I hear that, because sometimes the internet connection goes away and I'm not aware of that, and I keep talking. It happens before, so it's not good.
For example, last week, teacher.
Yes, I was talking, and you weren't there. I'm sorry about that. Okay, so let's open that. Okay, chapter 5, fundamental theorem of calculus. This is very important. This is the one of the main theorems of calculus, as you would know. Okay, I'm gonna make this smaller. I mean bigger, sorry, not smaller. Okay, so let's look at this fundamental theorem of calculus part 1. Actually, it is bigger than it sounds. Okay, let's look at that. Okay, I want you to, let's make it a little bit bigger for you again, like this. Very good. Okay. Fundamental theorem of calculus part 1 says this. If f little f is a continuous function on AB, then we define a capital F, okay, from a to x, f of t. So by using this little f, we define a new function, capital F. And this capital F is automatically continuous because little f is continuous, okay? And actually it is differentiable. It's more than that. It's differentiable. And we can find its derivative. The derivative of this capital F is going to be equal to just little f evaluated at x. That's that simple. Okay. Now I want to show you some examples here. They are really nice examples for you to practice. Use the fundamental theorem to find dy dx. The first one is easy. The reason is it is in the form of fundamental theorem part 1. So what do we do? If you look at the answer, dy dx, what is our little f? Little f is t cubed plus 1. You just evaluate that at x. That's easy. But if you look at b, it's just a little bit different because x is not on top now. So the limit is interchanged. So whenever the limits are interchanged, you want to put it in this format. Okay, x is up. You want to put it up. But there's a price to pay. If you want to change the limits of the integration, you have to make a minus. Put a minus. This is the price you pay. You put a minus in the front, and instead of x to 5, you have now 5 to x, which is in the format that you like. And then afterwards, you apply fundamental theorem of calculus part 1, and it says this is a little. So we take the negative out. Little f is 3t sine t. You just plug it x in it, and you got the answer. Now we are going to make the question harder. Look at the C. In C, look at the upper limit. It's not x anymore. It is x squared. So this is new. So how are we going to deal with it? So instead of x squared, I'm going to rename it. I'm going to make a substitution, and I'm going to call it u. Let's get the solution here. Okay, we are going to let u to be x squared, and I'm going to write the function as y is equal to 1 to u cosine t dt. And remember, y is a function of x. I want to take the derivative of y with respect to x. But there's a chain rule, because first y goes to u, and then u goes to x. Okay, so there's this dependency rule. Y depends on u first, and then u depends on x afterwards. Because of that, we have to use this chain rule to do that. The chain rule says dy dx is equal to dy du. You take the derivative with respect to u first, and then don't forget to take the derivative of u with respect to x and multiply with it. Okay? We are going to follow that. The derivative of y with respect to u is, okay, it is just, the integrand is cosine t. It's just cosine u. And what's the derivative of du with respect to x? U is x squared. Take the derivative, you get 2x. So the answer is, okay, cosine u 2x. But instead of u, you have to substitute what u is in terms of x, and it is x squared. So we have cosine x squared times 2x is the answer. Okay, this is just a little bit different, as you would see. Any questions until here? Any questions? Okay. We have another version. So in D, on the other hand, we have to change the limits. Okay, we are going to first change the limits and then do the work, which you will see it in the next screen, I guess. Okay, what's the derivative of this expression? We first pay the price and change the limits, and this function is up now. That's good. And then we apply this chain rule. The chain rule says if you want to take the derivative of that, it is, if you consider this like f, it's going to be f of u times the derivative of u with respect to x. Okay, f of u, this is f evaluated at u, which is 1 plus 3x squared, times the derivative of u, which is 1 plus 3x squared. If you take the derivative, you get 6x from here, coming here, and then, isn't it 6x? And then in the denominator, we have 2 plus 1 is 3 plus 3x squared, so 3, take it out. Then 6 over 3, you get 2 on top. And we have the minus, don't forget about minus, which we paid the price to interchange the limits. And you get this as an answer. Okay, is this clear? Is this clear, guys? Okay, so these were the harder questions than the one that we did. Okay, if you have any questions, let me know. Okay, so I'm going to continue. If you don't have any, you can write it in the chat if you have any questions, or tell me to redo it or something. Okay, let's look at this, and I'm going to do the screenshot again. Okay, so here's the screenshot. I love that. Okay, let's get to it. Okay. All right, this looks perfect. Okay, great. Okay, let's do the solution. So what is the what's this integral? What's this integral? Okay, solution. Okay, and here, so remember the derivative of 10, the derivative of this, like, I mean, d over dx, I should say, is equal to secant squared x. So antiderivative of secant squared x, tangent x. So I know that this integral is going to be, okay, let's call it I, integral I here, integral I, and then the integral I is equal to 4 times tangent x, okay, 0 to pi over 4. Okay, so I just put in the values for tangent pi over 4. Okay, I'm gonna do it like this, minus tangent 0. But this is 0 because this sine over cosine, sine 0 is 0. Tangent pi over 4 is 1. So the answer is 4. Okay, this is done. Any questions? If you may have any questions, please do not hesitate to ask me questions. Okay, let's continue. All right. Okay, this is good. Let me do the snapshot again. Okay. And I have to copy these as well. Okay, let's get to it. Okay, good. Go down a little. Okay. And then snapshot of this. Actually, there are lots of that. Okay, maybe this much. Okay. Okay, let's do that. Let's make this a little bit smaller so that we can see it. Let's move it towards right. Okay, good. So it says here is the functions f and g are integrable. 2 to 4 f of x is -5. 2 to 7 is -6. 2 to 7 of g is -5. So we have f and g are integrable functions. Okay, so it says 4 to 4 f of x dx. Whenever you integrate, if the integration limits are the same, the integral is equal to what? x0, yeah? Okay. All right. And then let's look at the second. 7 to 2 gx. 7 to 2 gx, we are going to interchange the limits. So it's going to be 2 to 7 g dx, gx dx. So it is a negative of that value. Let's go up here. Let's go up here. G. -5 times negative, it is 5. So we got that it's 5. Okay. And 2 to 7 g at 2, times 2. This is, you can take the 2 out. So it is 2 times -5, yeah? Which is -10. So let's write it. This is -10. And then let's go down. 4 to 7 f of x dx. 4 to 7. Let's get 4 to 7 f of x dx. I was given as 2 to 4, 2 to 7, but I'm not given 4 to 7, so I have to figure that out. Okay, so I'm going to do it as follows. Okay, so this thing is actually equal to, let me do it. So this is 2 to 7 f of x dx minus 2 to 4 f of x dx. Okay, so I think this was a -6 and the other one is -7, I guess. Let me double check. -5 and -6. Okay, -5 and -6. So this is -5. This is -6. -6. So the answer is going to be -6 plus 5, which is -1. Okay, that's it. If you have any questions, let me know. Okay, there's more. These are easy, but let's do it if you like. Okay, let's go down if you have more. These are the answers that are given. Okay. Okay, let's get it here. I'm going to copy here. Okay, and then this time, what does it say? G minus F. 2 to 7 G, what was it? 2 to 7. 2 to 7 G is -5. 2 to 7 F is -6. We take the differences. -5, -6. Okay, so this is going to give us, okay, -5 minus -6. Yeah, this is going to be 1. Okay, because you can separate it. Okay, this is 8 times of that. If this is, so this is going to be 8 times 8, -5 minus -6, -40 plus 6, which is -34. Yeah. Okay. So this is all to it. Okay. Next question. This is faster, maybe copying, pasting, etc. Instead of opening up my lab and getting it from there. Let me see. Okay. Okay, so we are going to copy it all down here. Okay, put it in. Make it a little bit smaller because it's too big and we may not see the question properly. Okay, it's good here. This is the question 6. It says use the substitution rule to evaluate the following integrals. So let me use some color here. Oh, actually, this color is fine, or maybe red. Okay. So here, I want you to observe that this is going to be our u, and what is du? Du is cosine z, dz. Yeah, and we have it here. Cosine z dz is here. So this is going to be du now. Okay. So let's do it on the side. Let's see. Maybe I should do it down here, or to the right, maybe. Not too much right, a little bit right. Okay, so the first one is, so I'm going to do A here, or maybe I should do B here. So B, so this is my U, and this is du. Okay, so integral. What you could do is you can change the limits, or you can leave the limits as they are. So I'm going to put a box here. So this is du over u, square root of u, I'm sorry. Okay, so I'm going to change, I'm doing the b first, okay? I'm doing b, and then I'm going to do a. So u is, pardon, z, sorry, undo, can I do undo? Okay. Here, the z values are first negative pi, and then another value is pi. So whenever z is negative pi, u becomes, so what is that? Let's move a little bit towards right. So I want to just do that, okay? Do this part. And then u is going to be, what is u? Let's write u somewhere. U is equal to 2 plus sine z, yeah? Sine z. So if the z is negative pi, this is going to be 0. 0 plus 2 is 2. Okay? And then if z is pi, put it in sine pi is 0, you get, again, u is equal to 2. Okay? So, actually, this is going to take us to, okay, this is going to take us to 2 to 2. So the answer is 0. Okay. Another thing is, another thing to see it, that it's going to be 0. Let me write it here. This is another solution. Okay. Second way. But this, you may not see that all the time. Okay. Second way. Second way is, what is f of z? F of z is cosine z over square root of 2 plus sine z. But they told you to use substitution, but this is without the substitution. Okay, f of z. Do you see that f of z is even? Even function, even. Since it is even, it is symmetric. Okay, it is symmetric with respect to the y-axis, right? So let's see. I want to make it 0, yeah. So just a sec. No, it's not even. No, it's not even sine z there. No, not even. I take it back. Otherwise, it's not going to give you that. Don't even consider this. The top part is even, but the bottom part is not even. So it's not going to work. Okay, this is not going to work. Okay. So we have that. So there's no second way here. And here, for this one, so the integrand is going to be, let's use it here. I don't have enough room here. Let's try to write it in here, okay? So this is going to give you, whenever, okay, so integral, this side is going to, u is going to be, whenever z is 0, this is 0, it is square root of 2. And by the way, it's square root of 2, not 2. Okay, just corrected. Oh, no, that's okay. Sorry, it's not square root of 2, it's 2. Because u is this. Okay, u is this. Inside the square root, yeah? Inside the square root. This is u. So when you plug in 0, sine 0 is 0, this vanishes, and you get 2, so this is 2. And when it is 2 pi, sine 2 pi is 0, this vanishes, and then 2 comes here again, it's 2. Okay, then this is du over u, du over square root of u, yeah? All right, so this is going to give you 0. Okay, because a to a, f of u du is 0. So we got that. Let's move down and do another question. Any questions? How many minutes do we have? We have 1 minute. Okay, so let me go through all these very quickly in 1 minute. So this one is telling you to, taking the limit of this, okay? Maybe I can copy this down and write it very quickly. Okay, answers are here too. Okay, let's do this as well, and then we stop. Okay, let's go up, make it a little bit smaller. Question 7. Okay, now express the limit as a definite integral where P is a partition of this. Okay, we are going to do it as follows. Look. So this is the limit of the Riemann sum. Yeah? Okay, this is Riemann sum. This one is, okay, just a sec. This one is Riemann sum, this one. Okay, Riemann sum. And you are taking the limit of that, okay, as the partitions of, as n goes to infinity, this is the same. That the length of the P means P is a partition of this. P goes to 0 means the n number of rectangles, okay, goes to infinity. It's the same thing, okay? So how are we going to do that? First of all, the domain is from A to B here. So I'm going to write the lower limit is pi over 6. The upper limit is pi over 3 of this integral. And what's the function that we use? Cotangent function. So it is cotangent x, okay, times, okay, dx. You're going to say, because if you convert it to integration, you get it like this, okay? Yeah. The first question is it delta xk or dx? The answer is dx. And if you calculate the answer, because they want you to find the answer, no, they don't want you to find the answer. They just limits pi over 6, pi over 3, and then this is the integrand, and then this is the dx, and you got it all. Okay? And you can always, if you have the limit of the Riemann sum, this is equal to the integration of it as follows. I think that's good enough. We have 2 minutes over time. I'll see you next time. If you have any questions, let me know. Okay, we'll do more problem solving sessions next week, and maybe on Friday as well. I will let you know. Thank you.